Grab project, gravity assisted pulse motor update. Let's see here. We've got the cap bank installed to dump, a large amount of current through the electromagnet. We had to go out and purchase a, a 12 volt starter motor relay or solenoid. So every time the, the micro switch cam triggers, it, turns on the starter relay. The small inverter that we purchased to power the device to supply 120 volts AC is just too small, I think, for the capacitor bank. It keeps going into like an emergency condition. So at this point we have it plugged into the grid, which is a bad thing. Anyways, but it's just to show that it does work. This is 20 pounds on the bob, 3x3 neodymium magnet, 100 volt, approximately 100 volt pulse through the electromagnet, and sounds like we have to do some modifications. Well, we're finding mistakes all over the place. We'll make modifications as we go along. 10-pound flywheel, and it seems to be holding pretty constant. We'll let her run for a while, see if anything catches on fire or goes into meltdown. We're on the right track, though. So we have the 12 volts energizing the starter solenoid, and that dumps the capacitor bank charge at 100 volts through a 4 ohm electromagnet. Yeah, there we go. And I'm looking at the end of the swing, and it seems to be holding pretty constant. And we're getting a nice RPM out of the flywheel, probably somewhere around, I haven't measured it yet, but 200 or 300. But you can stick a small load on it, and it slows down, but it doesn't come to a stop. Let's see here. What else? Looks like the electromagnet timing or the camming switch needs a little adjustment. We can do that. We'll take care of that. But you give it a little manual assist, and it perks right up again. Anyway, so it's basically working. It's probably just a small, bunch of fine tuning. If we were going to pursue this approach, let's see, we'd need a much larger inverter, or a smaller capacitor bank. I think is probably a good start. And but we'll give it a couple of more days. Basically, I'm kind of interested in seeing what the centrifugal force or two-stage oscillator will do, and that's just a what is it? An unbalanced bicycle wheel spinning at a high RPM, creating a pulse on a teeter-totter configuration or lever and fulcrum configuration to drive basically the same style transmission we have on this device. Let's see here. Goes to there. Goes to there. Yeah, it seems to be holding constant. It seems like we could get some sort of electricity out of the device. As I said, as soon as you stick a load on it, it drastically subtracts from the swing, the length of the swing, and that affects the overall performance. And it just doesn't regain the swing duration. So there are definite problems with this approach. We can try it with 40 pounds. Try to get more of a more amplitude at the ends. I think that increases the the amount of potential energy to the system. But there again, as soon as you draw any energy off of the system, it greatly reduces the swing of the pendulum. So I think that's the biggest problem with this sort of approach. But we'll do a few more modifications and a few more tests and post results when available. Something broke. No, the chain came off. Yeah, so right now it's under basically a no-load condition. And you can see how the swing really increases without a load on it. Anyway, so we'll make modifications, post results when available. Enjoy the day. Thanks for watching. Cheers. Let's see if we can get this all the same shot here. So there again, it's 100-volt pulse at the electromagnet, which is 4 ohms, and you can see the chain just fell off the transmission. Anyways, but it definitely increases the pendulum drive. So this is unloaded before it starts swinging in a full 360. I think we'll turn the device off. Anyways, enjoy the day. Thanks for watching. Cheers.